Hey everyone, welcome to my channel. In this video, we will continue building our multilinear regression model for prediction of house rent. In the previous video, we imported the data and cleaned it up. Now we will split it up and train to get the final result. So without further ado, let's get started. So here we are in the pie chart, and you can see that we have our multilinear regression folder, and inside that we have our house rent.py file, which is our main file, and then we have the data by the name houses to rent, which is a CSV file, which stands for comma separated values. Now in the previous video we imported our libraries, and then we imported the data from our pandas library. We took some help of that, and then we used the data.head method to actually print out the first 5 rows. That actually gives us an idea of what the data looks like. And then using some pre-processing techniques, we removed the extra values, extra things that we had like rs and the comma, and then we converted our furniture, which was furnished and not furnished, to 0 and 1, because the machine learning model cannot understand strings. It has to be zeros and 1. So at the end of the day, this is what we had. So this is what we started off with, and this is what we ended up with. So that is good so far, and now we are going to look at how much data do we have that does not have an actual value. So this is called NaN, or which stands for not a number. So we will look at how many of these does not actually have a number. So before we do that, let's just organize a little bit of our output. So let's write here print, and we are going to write dash. So let's put a dash, and then we are going to multiply that by 30. So we need 30 dashes, and then we are again going to print, and we will write here checking, let's say, null data, and then we will copy this again and we will paste it here. So what this will do is it will give us a heading. So you can see here we have this nice heading that says checking null data. So that is good. We can give a heading at the top here as well. So we can say, let's say, importing data. So let's write it here. So we can write here importing data. Okay, so let's run that. And there we have it. So importing data, we are looking at the data here, and then we are checking null data. So let's start with that. So what we will do is we will simply write data dot is null. So we will write that, and then we are going to write dot sum. So this is a very simple method. It sounds a little complicated, but in fact it's just one line of code, and that will give you pretty much everything you need. So if we write that down, it will tell us which of these basically have null data and how many of the values are null. Okay, so lucky for us, none of them have any null data. So that is a shame, because we want to see okay, let's do one thing. We can go back, and we are using city. So let's put here NaN, and let's put here NaN. So now we have 2 null datas and data entries, and what we can do is we can run that again, and there you go. So city has 2 null data. So that is something that we have. So here you can see NaN and NaN, and here as well you can see that. So the good thing is in our data we don't have any, so we don't need to worry about that. But if you had, what should you do? That is the question, right? So what you can do is you can actually use the drop method. So you can say that data dot drop, and you will drop NA, which is the null values, and that is pretty much it. So you will just put it back to the data. So you will write data is equals to data dot drop NA, and if you run that, no, we have to copy it again. So if we run that, you will see that earlier it had 2, now it does not have any, because it has dropped all the data that had null values. Now, but this is not good if you have a lot, or if you have very less data. If you have a lot of data, then you can skip a few of them, right? Even if you skip 1 or 2 or 3% of your data, it doesn't matter that much. But if you have very little data and a lot of it has null values, then you cannot do that. In that case, you can put the average value, or you can put, for example, a 0 value. It depends on the situation. So in this case, we don't have to worry about that, so I'm not going to go into that much detail, but there are methods in which you can replace the data with an average, or you can replace it with a constant value, and in the later videos we are going to see how we can do that as well. So for now, we don't need to do that. We can just remove this, and I will keep this here in case you want to use it with some other data. And let's print out the head as well. So let's just copy this, and here we can write head, and yeah, and here we can simply write print, and then okay, so let's see. I'm doing this because this is pretty much the last step before we are actually going to send in our data for what do you call it, the training process. So this is the head, and we can see that everything. Why is this saying NaN? See, now we are, oh yeah, I didn't replace it back. That's why. So we need to put it back. This was 1 and this was 1 as well. So see, this is why it's useful to know at the end is if everything is good. So now I can see pretty much everything looks good, and it is ready to send to our model. And before we send it, we are going to split it. So let's copy this, and we will write here, let's write split data, and we can use this as well. So we can write here split data, and then the split is actually fairly simple. But before we do that, we have to now split our data into X and Y. So all the attributes that are inputs that need to go in X, and all the attributes that are all the output has to be in Y. So here we have how many do we have? I think we have 6 inputs. Anyways, so we will write X is equals to data dot drop. So we need all of the data from this data except for 1, right? So we can simply say drop this one and keep the rest. So that's what we are doing. So we will write here that we want to drop the rent amount, because that is our output. So we'll write here rent amount, and then we also have to define the axis we want to drop. So the axis is 1. Then we have to define the y. The y is simply your data at the rent amount. So we will write here rent amount, and that should be good. And one thing we have to do is we have to convert it into numpy array. So we will write here numpy array. This is just something that the machine learning model requires. So we will write here numpy.array. Why is it not working? Because we did not import. So we will go up here and we will say import numpy as np, and we will go back, and there you go. So now we can simply write print, what should we print? Let's print the x. So we will say x dot shape, and then we will print y, and we will say y dot shape. Okay, and let's run that. And there we go. So when we're splitting the data, we can see that we have 6080 values. So these are the instances I was talking about. And then we have 6 attributes. So this is our input, and our output is 6080, which is 6080 values. And that is pretty much good. Okay, so next we have to split this data. So we will write xtrain, and then we will write xtest, test, and then we will write ytrain, and then ytest, and then we will write equals to sklearn. Did we import it? I don't think so. Yeah, we didn't. So we will import sklearn, and we will also import, what was the name of it? It was linear model. Yeah, this will use later on, but since we are importing, let's import it now. So we will write here sklearn, and then we will write dot model selection dot train test split, and then we will give the value of x and y, and then we will write the size. So we will write test size is equals to, let's say, 0.2. So we will use 80% for training and 20% for testing. And then okay, for now let's just use this, and then we can write here. Okay, so then we are going to print again. We are going to print our xtrain, and then we will print the value of xtrain, and then we will write print, and then we will print the value of xtest. So we want to see how much the split has been. So I forgot to write the shape, not shape. So let's run this, and there we have it. So our data was 6080, but now it's 4864 for training and 1216 for testing. And again, we have 6 attributes for both of them. So it seems that everything is going smooth so far, no errors, which is a good thing. And finally, we can head on to the training part. So let me just copy this, and we will paste it here, and we will write here training. And over here as well, we will write training. Okay, and then we can simply write model is equals to linear model. This is the one that we imported over here, coming from scikit-learn. And then we are going to write here dot linear regression, and then we are just going to fit the model. So we will write model dot fit, and we will fit it with the xtrain and the ytrain, and that should be good. Let's just try to run it, and that's good. So we didn't find any errors, we didn't get any errors, so that is good. And now we can simply write the accuracy is equals to model dot score, and then we will write xtest, and then we will write ytest. So that should give us our accuracy. And prints. Now before I actually print the accuracy, I want to show you the intercepts, the intercept and the coefficients. So as I have mentioned before, if you have multiple linear regression, you will have multiple gradients, which means you have multiple coefficients. So let's see how many we have. So coefficients, I don't know if the spelling is right. So let's just write that, and then we will write model dot coefficient. Okay, and then we will write print, and then we will write intercept, and then we can write, let's put a space over, and then we will write model dot intercept, and this is coefficients and this is intercept. So let's print that out, and there we have it. So because we have 6 attributes, we should have 6 gradients. So we have 1, 2, 3, 4, 5, 6. So when we had one attribute in our previous example of when we were converting from Fahrenheit to Celsius, so in that case, I think we were doing the other way around. Anyways, so in that case, we had y equals mx plus c. So we had only one m. But now we have 6 attributes: number of bedrooms, number of bathrooms, whether parking is allowed or not, things like that. So we have 6 of these. So we have 6 gradients and we have 1 intercept. So this is the value of c. So using this, we can literally write down the equation and put in the values, or we can use the model.predict method to actually predict. So that is the easier way to do it. But before we do that, let's print out our accuracy, because that is the most interesting part. How good did we do? So let's write it down here, accuracy, and then we want to display the accuracy. Now this is in decimal places, so we can round it off, but we should multiply it first. So let's multiply the accuracy by 100, and then we will round it off, and let's say up to 3 decimal places, and at the end of it we can just write percentage. So let's run that, and there we have it. So we are getting 97.572%, which is very good. So if we run that, let's see again, do we get the same? Pretty much the same value. And so if we go back and we tweak these values, we might get different results. So let's put the randomization to 0, and let's put this at 0.1, and let's run it again. So you can see now it's 97.4. Earlier it was 97.5, I think. So let's put it back to 2, and let's put this to 10. And now you can see it's 97.572, and that sounds good. So this is our accuracy, which seems very good. Now one thing we can do is we can manually test it to see everything is working fine at the back end, right? So here we can say that we are going to test it. So we will write here, let's say evaluation, and here we are going to copy this, and we will write manual testing. And so what we can do is we can use the model.predict method. So let's say that our test values are basically model.predict, and we want to use the test values, right? So this is basically what this function is doing, or this line of code is doing, but we want to try it manually and see what kind of error are we getting. So let's say if the price was supposed to be 5,000, what is the value that we are getting? Are we getting 4,000? Are we getting 10,000? Are we getting 20,000? What is it that we are getting? So because here we are just getting one value, the accuracy value at the end, it's not giving us the details that we require. So here we can do this to actually get the values each of these predictions one by one. So if I print this out, so let's print out the test values. So our values are how many? The test values are 1216. So we have over 1200 values. So it will check, it will put 1200 values in the model, and it will print out each of these values. What happened? Why didn't it print? Yeah, so it's not showing us all of this. So we can just write shape, and we can run it again. And there we go. So it's giving us the 1200 predictions that we need. So what we can do is we can now check the actual value and the predicted value, and then we can compare how much deviation do we have. So we can write for, let's say we want to iterate through this test values. So we can write here for test value in test values. We want to append, let's say error dot append, and our error is basically y test at I, the current iteration, but we don't have the value of I. So what we can do is we can write here I, and we can make this enumerate. So enumerate, so this will give us the count. Otherwise you can put a counter as well. You can write here count is equals to 0, and here you can write count plus equals 1 every time. It's the same thing, but this one is a little bit better way to do this. It's a little more efficient. So here we will write error, and I forgot to declare error. Error is an empty array, and then to find the error, it's basically y test, which is our actual value minus the predicted value. So it will be our test value. So this is our error, and then what we can do is we can print out f, and then we can write here actual value, and then we can write, let's say, what is the actual value? This is this y test I, and then we can write that we have the prediction value, and it's getting bigger. Let's just remove value. So this is actual, this is prediction, and over here we can write the test values at I, or no, it's actually the test value, so we don't have to write I. It's pretty much the same thing, but we have to write test. One more thing will be that the prediction will be in decimals, so we don't want the decimal values, so we can just write integer. Okay, and then we can write the error. The error is basically your error at this iteration, and then again we don't want we can round it off, or let's just make it integer, and there you go. Okay, so now the bad thing about this is it will show us 1000 values, so it will be hard to move around, but again we want to see all the values, let's say. So let's run this, and there you go. So if we go all the way to the top, this is where our manual testing starts, and you can see that, let's say this is our actual value and this is the predicted value. So let's say that we see 1200, and it is actual, the prediction is 1300, but the actual value is 1200. Then over here the prediction is 6588, but here it's 7000. So you can see here you have 2200, it is 2100. So the values are not that far away, and this is not so bad. So if you think about this, let's say somebody told you that the prediction is that you are going to pay the rent of 1664, but the actual value is 1150. So it's not that far away, so you won't get mad, you gave me the wrong value. It's pretty much close, and it seems that the 98% or the 97% actually it's working well. Some of these values are actually large. You can see, for example, here you have 700, but for the 700 value you can see the value itself is quite huge. So you have 12,000, and here you have 11,900. So again, when you're talking about thousands, if it's 11,000 or 12,000, it's not that far apart, so I wouldn't say it's that bad. And for smaller values, you have smaller errors. For example, this 2000, you have only error of 22, so that is good. So as you can see, we have all the errors here, and we can see what is our actual value and what was the predicted value. So at the end of the day, we are getting the accuracy of, where is it, 97.5%, which is very good. And again, this is not a very advanced technique. This is linear regression, and there are other methods that will give you more what do you call, in terms of accuracy. So later on we are going to look at these other methods as well, but for now this seems to be a good method and a simple method that you can get started with very easily. And you can see that it is not something very complicated. It's only a few lines of code, and you're able to create your own model that is able to use real world data and give you real world predictions that you can literally use. You can embed this on a website that will ask you the location of the place, the number of bedrooms, and it will estimate you the price of the house. So which is something you can actually use in real world, and which is actually useful. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up, and I will see you in the next one.